Hi everyone, I'm Isa from Undo. Debugging multiprocess applications in C and C++ is really hard. You've got forks, shared memory, multiple processes communicating, sharing resources, and when something goes wrong, figuring out which process messed up can take forever. In this tutorial, I'm going to show you an easy way to find a race condition in a multiprocess C program. Here's my program, and here's my source file. When we run the program, we get an assertion failure in one of the processes when accessing a shared structure. So let's kill that and figure out the root cause together. First, we need to record the problem happening. I know that this program uses forks to create subprocesses, and we know that there's a bug accessing shared memory. So let's start with a normal LiveRecord command line. And then to this command line, I'm going to add on fork both and mpc-shmem. OnFork tells LiveRecord to record both the parent and child processes, and mpc-shmem tells LiveRecord to track all the accesses to shared memory in all recorded processes. I will pop a link in the description to the documentation for both of these. So now let's create some recordings. We can see that the assertion has failed again, and we've recorded it. And if we Control-C, that will stop and save all of the recordings. So if I ls, I can see we've got 4 recordings, one for the parent, and 1, 2, 3, one for each forked child. So we can see that the assertion failure happened in this recording, this process, since the recording was saved immediately after this. So let's load this recording in UDB. And what we'll do is we'll continue to the end of the recording and replay through the assertion failure. So you can see that the replay has printed out the assertion failure again. So let's go and figure out what's actually happening here. So if I switch into 2E mode, that will show us some source code. We don't have any source code because we're deep in the C library at the moment. So let's get back out of the C library with reverse finish, or I prefer just RF, and we'll keep running that, keep doing it until we get back into our own code. Great. So let's inspect what's happened here. So this is the assertion that failed. If we look at G shared value, it is 19,637. Old value is 1 less, 36, and A is 0. So indeed, this plus 0 does not equal that. So what I'm going to do now is set a bookmark here. I'll call it failed, so we know. So this is just so we can keep a record of this time, really, and so we can jump back to it easily. So let's go have a look at where this old value came from, and we can see it's just a few lines up. So we could just reverse next to it. I'm going to use last because I can, so last will jump to the last time this was updated. So that's taken me up to here. And this is the value we expected to see. And just to check the shared memory address, shared memory value. So indeed, that's 19636. So let's bookmark that as good. So we know that it was ended in 36 here, and then despite the fact that we only added 0 to it, it was 37 by here, which means that some other process updated it between here and here. And although this is a small demo program, I've been in this situation many times with real world programs where you're looking at it and you're going, something else changed it, but what? And that's where we can use the ublame command to find out. So I'm going to switch back out of 2E mode just to get a bit more screen. And I'm going to go back to, if I type info timeline, I'm just going to jump back to where it failed. Sorry. Okay. And I'm now going to use the ublame command. The reason I jumped forward is because the ublame command will show you all of the accesses up until where you are in the recording. And obviously I want to see what went wrong in between these two. So the syntax is ublame and then an address, which we want gshared value, right? Here are all of the accesses to this address, and I can just quickly talk you through these columns. So number corresponds to the inferior number. Inferior is a GDB term. For us, it corresponds to a recording. And you can type info inferiors, and it'll tell you the PID and what recording it corresponds to. Time in recording is the BB count and PC. Whether it was a read or write, the address, which is all the same because I passed it an address, and the length of the access. So if we remind ourselves of our timeline again, we are looking at things were good at 394, things were bad at 401. So let's find them here. Here we are, we're doing a read, 394, and then doing another read, 401, and in between the two, you can see a write from inferior number 3. So we need to find out more about this, and that should take us straight to the bug. So it's at time 450. So I can say you go inferior 3, and then I can go to this time, you go time, and I'll just copy the whole thing. Okay, paste. And then, yeah, if I switch back into TUI mode, do you go time, and here we are at an increment. And as you can see, we've got a lovely comment above it that says this is unsafe because there's no mutex protecting it. So the fix for this bug would be to wrap this access in the same kind of lock as we've got here. So to recap what we did, we recorded the failure using Undo's recording tool, which is called LiveRecord. We loaded the recordings into the debugger, which is called UDB. We replayed to the problem, and then we used multiprocess correlation to find the bug. Debugging multiprocess systems is especially hard when timing issues are at play, but with Undo, you can record everything at once to track down those tricky timing issues, rather than spending hours adding printfs and rebuilding. If you'd like to try these debugging techniques yourself, please check out the links in the description. I hope you enjoyed this video. I'd love to hear about your experiences debugging multiprocess systems in C and C++. So what debugging techniques have you found most effective? Are there other debugging techniques or processes that you'd like us to explore? Please comment them down below. And I'd also love to hear any questions or comments or suggestions about this video. If this was helpful to you, please remember to like and subscribe. Thank you.